So 5 years ago, this open source container registry application had a vulnerability. And in this video, we'll walk through and showcase that vulnerability, CVE 2019-16097, in the software Harbor. Now this is open source software, so you can find it online at github.com/goharbor in the repository Harbor, or on their website goharbor.io. Now, please let me say, this project is still actively maintained. You can see commits here from like a couple days ago at the time of recording, so it is alive and well. Now with that, I don't mean for this showcase or this video to be perceived as any sort of ill intent or slight for them or their project. I just want to showcase this as another educational demo and to note, look, anyone can be affected. But the vulnerability, CVE 2019-16097, notes that in this software, in the file path core/API/user.go, in earlier versions, it would allow non-admin users to create admin accounts via a simple post method across their API, and API/users. This is in the case when Harbor is set up with the database as the authentication backend and allowing users to do self-registration. It's been patched for years now. Again, this is 2019, 5 years ago, so versions 1.76, 1.83, 1.90 are all fixed. Anything onward is good to go, but let's go explore this Harbor software, see if we can find the vulnerability and recreate it. So let me go ahead and git clone the repository here. We'll copy this, and I am inside of my Kali Linux virtual machine, so I'll go ahead and hit Control-Alt-T on my keyboard to open up a terminal, F11 to full screen, and I'll zoom in with Control and the mouse scroll wheel. Now let me make a directory for Harbor so we have a place to work, and with that we'll go ahead and git clone the repository, pasting in the link that we received from GitHub, and with that we'll pull down all the source code for this open source application. Look at that, looks like it is complete. Let's move into that Harbor directory and we can see everything present here. Now, if we wanted to recreate the vulnerability, obviously we should get to the vulnerable version of the application. Going to GitHub, hey, taking a look at the latest changes, obviously we're going to see the most recent release, version 2.11.0, but we need to go all the way back to version like 1.75. You could take a look at the README, we could get a better understanding of what the application is, all that it does. You can parallel it to, I think, like Portainer, just a application to manage a lot of different Docker containers, images, registry info, etc. A lot of really neat stuff, but honestly, we want to go ahead and install a previous version. So if we were to go take a look at the previous releases, let me zoom back out, scroll back up there, you can see there are other 295 releases to dig into. So let's go explore those. On the releases page, we can make this a little bit easier for us if we actually go explore the different tags for each of the versions. That'll bring us to, you might have seen at the bottom left, the URL here, or in our address bar, Go Harbor, Harbor tree, and then the version that we'd like. We could actually toggle this, change this to 1.7.5, as remember, that is the version prior to a fix in version 1.76. So let's go to 1.75, and now we can see everything, again, from 6 years ago, from 5 years ago. This is around the timeline where the vulnerable code would have been part of the code base. Back on the command line, actually taking a look at our local copy, we can run the command git tag to see all of the tags that are included here and all the versions. Obviously, scrolling through this, you can see all of these different versions, scrolling all the way up to 2.11, the latest. Now, let's go to that git tag, and we'll specify when we want to check out some of the tags we'll want to get to that version 1.7.5. You will need to be explicit when you specify that on git checkout tags / that version, and with that, we'll hop over there. Now, we could take a look at the git log to see the recent commit messages. Hey, that's around 2019, so we're in the right timeline. But we want to be able to run this application and play with it. So let's go get that copy, the official release, from, again, the online GitHub. If I pivot back to the releases, you can see now this link will actually tell me, hey, we're looking at the releases for that tag version 2.11.0. Let's go to 1.7.5 in our URL. That'll bring us there. If we download the binary, we have the open source Harbor project with either an offline or an online installer. We can go ahead and grab that link. We'll copy that so we can wget it down and then set it all up. Anyway, let's get back to our command line where we did have the source code in the GitHub repository cloned, but let's move out of that directory and let's wget down the online installer, that tar gzip file that we were just given the link to. We'll go ahead and download that. We can see that is present in our current directory. So let's tar x to extract, z for gzip, v for verbose, and f to specify the file for Harbor Online Installer. Go ahead and extract all that, and that moved it all into the Harbor directory, so goodness, that probably made it even more confusing. But okay, let's go ahead and install, let's actually sudo that. So we can go ahead and set that up with Kali. I entered Kali as the password for Kali. Again, sudo will prompt for your password, but the virtual machine is just set up by default. However, we get an error. We do need to set up the host name. And we actually, if we read the documentation, a little RTFM, we could have seen that. Let me pivot back to the GitHub repository so we could go take a look at the README and see what some of those installation instructions were. Now this is all the insight to install and set up Harbor on a local copy for us. The online installer and the offline installer, either one doesn't matter for us because we have an internet connection, but we do need to update our harbor.cfg or configuration file. It's deployed as several Docker containers and therefore can be deployed on a software or Linux distribution that'll support Docker. You will need Python, Docker, and Docker Compose to be installed, so I'm good in my Kali Linux instance. The installation steps are really just download the installer as we've done and configure this configuration file. We'll run install.sh as we saw, my mistake. Falling down the rabbit hole, really we do need to actually set some required parameters or optional parameters for this configuration file. It looks like, if we actually drill down here, the only one that we really need to change is the hostname attribute. So if I were to go modify that harbor.cfg, now we can toggle that to whatever we want. Let's get back to our terminal and let's see if we have our harbor.cfg file here. We do. Let's open that up in a text editor. I'm going to use Sublime Text. Of course, you can use whatever you'd like. And with the harbor.cfg file open, let me actually set the syntax here to bash so we have a little bit better syntax highlighting in colors. The only section that we care about right now is our host name. We could set this to whatever we want. We'll call it like Harbor Kali. And if you actually scroll down, we can get a little bit more insight on other things set up for the application, a couple defaults, and even a default admin password that we'll use to log in. If you wanted to change this, of course, you could, but Harbor12345 is worth us noting when we start this thing up. So let's get back to it. Let's minimize this, try to sudo install one more time, and that will pull everything down here for us. Looks like it's looking good. Harbor has been installed and started successfully. Now you should be able to visit the admin portal at /HarborKali, HTTP to denote, hey, a little protocol for us in our web browser. We set the host name Harbor Kali, so this was accessible other than just localhost. Let's open that up and start to interact with it. Now, over in our web browser, we have Harbor ready and waiting for us to work with it. We could log in here and we know the default credentials. I believe that username should be admin, and we saw the password was Harbor, capital H, 12345. Let's see if I can log in with that. And there we go. Now we can see all the projects here. Projects, repositories, a library of things that we might be able to fill out with different images, instances, etc. We could take a look at the logs. I'm not going to fall down the rabbit hole to showcase all the use cases of the application. Obviously, we're here to showcase the vulnerability. But in the administration section, since we are going to end up creating a new admin user thanks to this vulnerability, CVE 2019-16097, that will allow us to create a new admin user, even from a low privilege user. So we should have that low privilege user set up and ready for us to work with. Let me create a new user here in this section. We can set the username to something like John. Email can be john@pleasesubscribe.com. First and last, yep, that's me. Password can be anything, I guess like anything1. Anything1, good by me. Comments is an optional field, so we don't need that. Let's just hit OK. And now we've created that new user. John is set up and is not an administrator. So let's log out of our admin account and let's try to now log in as John, our low privilege Joe Schmo user, just John. And there, we no longer have the admin tab and we just really are using Harbor for its intent and all the other use cases. Now, finally, let's start to go look for this vulnerability. I'm gonna go ahead and use Sublime Text once more to open up this entire project, this entire folder, and we can start to click into things and explore any of the source source code that we're interested in. Here you can see the harbor.config file again, the install.sh script that we just ran, Docker Compose, and of course the source code to the application where we could drill down into any specific folder and start to take a look at the actual work here. You might have noticed that this is written in Go, at least from seeing like the repository languages, and now that we can actually explore the source code, you could see all of these utils.go, all the files are .go file extension, and we could explore the source code here. Now that our environment is all set up, we can finally track down the vulnerable code and create our own proof of concept exploit for this vulnerability CVE 2019-16097. But before we do, since we've been chatting about open source software and Docker containers and all, I'd love to tell you a little bit about the sponsor of today's video, ChainGuard. Open source software is the backbone of modern development, but companies still struggle with maintaining patches and adding defenses and protections. ChainGuard addresses the biggest challenge in open source software: security. Founded by some of the industry's top experts in open source technology, cybersecurity, and cloud-native development, ChainGuard offers the largest library of secure by default, containerized open source software. They're trusted by top-tier companies like GitLab, Canva, HPE, and so much more. They help companies save time and resources by ensuring compliance and confidence in their open source software, all to empower organizations to bake in security across their entire operation. With ChainGuard, you don't have to shift left when you start left. Get started with ChainGuard and start building securely with my link below in the video description, jh.live/ChainGuard. Huge thanks to ChainGuard for sponsoring this video. All right, now back in our Harbor source code, let's go take a look at some of the models, especially the abstract representation of a user. So I've been drilling down into the source code folder, src, and we were in common here just a bit ago, and there is one directory here for models. So I want to expand that, and I want to go take a look if we have a user.go. Looks like we do, and this is the package models, of course, here. And you can see there is a user table, setting that up in the database, and the user struct. The user model holds the details of a user. We can see their user ID, their username, email, password, real name, and comment when we were creating it within that model form from the web interface. But there is one interesting one down here called hasAdminRole. It's a simple Boolean, and you can see all these comments, sort of, hey, tags along the side with ORM. I believe that's the object relational mapper. This denotes how it's also represented within JSON, that JavaScript object notation. We see this for all of the fields, and we see this for our hasAdminRole property just as well. So this is some worthwhile insight. If that's all that it's using to determine whether or not a user is an admin or not, hasAdminRole, just a Boolean, can we tamper with that? Is there any opportunity to actually manipulate that for this vulnerability, CVE 2019-16097? I'm sure you're tired of me saying that. Well, we knew from the CVE information that we saw online, this actually affects core API user.go. So nice, kind of speed runs a little bit of the source code auditing that we might do, review here. But we could, of course, trace down, follow the logic, control F or grep for whatever the heck we wanted to with any usage of this user struct and the model. Let's go over, though, to that directory that we're looking at, core here, and that should include the API folder and everything that might do with different models. But down below, we should be able to track down user.go. Now, this is cool. This tells us all of the logic for the API and the real brain of our application here. User API, base controller, password requirements, all these structs set up, and then some validation, validator functions, all that convenience. What we're going to be looking at are all the actual functions and methodology, what we might do for different HTTP requests that come through to the API. Here you can see a get method, and that will get a user or list these all out. I am curious, though, about the post method, because that's likely going to end up creating a new user. In fact, we could actually experiment with that the way that we did with the web application. If I bounce back to Harbor and actually log out of that John user that I was in, let me get back to our admin user. Over in the user section for administration, if I actually open up the developer tools, the network tab within our web browser, that's F12 on my keyboard. Let me toggle to the network tab here, and I'll click that, create a new user dialog box. Let's create just a testing user that can have the email test@test.com, testing 1. Now you can see a couple requests that did come through down below in our network tab. But now if I were to actually go click the OK button and submit to create this user, we see a couple other requests here. There is a post to users as the endpoint. It's going to the /API users endpoint. And obviously if I bring this down, you'll see our new testing user created, not an admin, but let's go explore what the request really contained. If I actually go take a look at this, this has our JSON object for a no comment, that was optional, our email field, password information, real name, and all the fields that we provided. Now let's look back at the logic here in the source code. Obviously our post function that's handling this, there's a check if auth mode is a common database format, status forbidden, and this conditional is a little bit interesting because we have inside of the parentheses here, if self-registration, presumably if that's enabled, or the user account is admin, we're checking if either of those are true in that OR statement. So self-registration is true, which means this OR will evaluate to true. But the not here with the exclamation point preceding will means that this condition will not pass through. So we won't see a warning here in a custom abort where registration can only be used by admin role when self-registration is off. So because self-registration is on by default, as you saw, again, under sign in, login, we could create a new user. Doesn't matter if we are an admin or not setting that up. We'll just pass right along through and we'll get to the logic here, where we grab a user object just based off of the model, a blank empty skeleton that gets filled out and populated with this UA, the user API, actually decoding the JSON request and filling it in to our user object. Following that line of code, it does do a validate call on that user object, but let's explore what that actually does. I hit Control F to search for it, validate when user register. Okay, so validate user model actually determines the username length, the username characters, password length, and then that's about it, returning common validate of user that checks for the email format, etc., etc., etc. But that's all just string value and data for what's provided. But if we go back to our decode request, that doesn't do any other checks for the contents of the JSON blob that's sent to it. And we know if we actually look back again at our common models, going back to our user.go, we could just try and specify in our JSON request here the has admin role property, just this JSON value. We could set that to true, could we not? Let's try it out. Back over in our web browser, let's take another look at the network tab in the developer tools to see we did pass in this object, but let's actually copy this request as curl, hey, the command line that we might be able to use, running that from the Linux command line. But let's actually build out a Python script to super easily exploit this. I actually want to create a new tab and search for curl to Python requests, so that way we'll have something simple, something easy to convert that curl command to code. If I paste in that curl representation, we can see the Python logic with the import requests library or package that we'll use. So we can copy this whole thing to our clipboard and then create a little small exploit script. Let's get back to our command line and let's subble an exploit.py. Paste in this syntax here just to kind of have a skeleton. If you wanted to add a shebang line, of course, hey, staying proper with all Python. We'll import requests, and the cookies is really from our current admin session. We're trying to demonstrate that this is worthwhile even from our low privilege John user or our testing account, right? So let me grab John's cookie just for the sake of showcase. Let's log out, log in as John. So let me open the network tab again, hit F12 on my keyboard. Let's go to that and let's just click into anything here. So we can see some of these requests to API endpoints. That's good. And now I want to just grab the cookie SID here. So we use that to say, hey, we've got the compromised low privilege user. Now let's escalate our privileges to create an admin account. Back in our code, let's change that session ID. We don't really need to include these headers here. So let me remove those. And then our data is what we might be able to manipulate. We can change the username to hacker. Email can be hacker@hacker.com. Real name can be hacker. Password can be hacker1. Comment is still an optional field, so that can remain as none. But remember, we need to add in that secret special sauce, where we could, nothing stopping us, to just include the JSON property has admin role separated by underscores, and we'll mark that as true. Again, it's just a Boolean value. And from the core API, we know this decode JSON request is just going to fill in all the values and populate it into that user struct. So this is the simplest thing. Let me go ahead and include the cookies. We don't need the headers anymore. We'll represent the JSON data being passed in. And let's go ahead and print out that response. I want the object itself just so I can easily see the status code and representation, and I'll print out the response.text. And that's about it. This is about like 23 lines, and it really doesn't have to be. Again, this could just be a curl command to exploit this. Oh, and actually, sorry, before we kind of fire the gun here, I believe the password field we saw in the logic for the validator, that does need to have 8 characters. Right now we're only 7, so let me add another one here for our stupid password, hacker11, that's fine. Now let's get back to our terminal and run our exploit script with Python. Let me fire this up. Response 201 doesn't include any content here, but 201 is a success, right? So let's go take another look at our users. Remember, this is the convenience of having our local testing copy, but if I were to log out of John, we could log in as admin to try and see if that came through, but we also really could just try to log in as our new backdoor hacker account. The password was hacker11, so let's try to log in, see if it exists, and it does. And the administration section is available to us. The users here, we see our hacker, we see, yes, we are an administrator, and with that, we can do whatever we want. We could manipulate the registries, add a new endpoint, hey, do whatever replication we might like, changing the configuration settings, do anything, because now we've been able to escalate our privileges and then wreak havoc in Harbor. Now bear in mind, this is a vulnerability from 5 years ago. Small, simple thing. But if we actually want to take a look at the new releases, it is patched, it is fixed, it is not a concern right now, and Harbor is still doing awesome and incredible things. But if we wanted to go take a look at the tag releases for 1.7.6, that is when they had made the change. That is when they properly patched and fixed this. You could actually see in the release information, the resolved issues include disallow creating an admin user when registration with the CVE link. It also includes information for the workaround, but let's go take a look at the commits. And here it is, disallow creating an admin user when registering, and the changes that they made are actually adding in to our user API post function methodology that we saw here, adding if it's not an admin currently, and the user has admin role, then it says, hey, a non-admin cannot create an admin user, logs the error, and sends that forbidden message. And credit where credit is due, this is actually a write-up from Unit 42, Palo Alto Networks, and some of the cool research that they had done. Their article notes, critical vulnerability in Harbor enables privilege escalation from 0 to admin, CV 2019-160971. Big shout out to Aviv Sasson, the security researcher that tracked this down. And the patch is kind of awesome. Like if we look through the pull requests on GitHub, they're kind of hilarious. They note the commit that they have this here, and then the responses are the classic GitHub, looks good to me. But the impact around this time in 2019 was kind of wild. There were about 1,300 Harbor registries open to the internet that had this vulnerable default setting, which means that, look, if you want to take advantage of this, noting all of the potential impact, they could delete all the images in the container registry, poison the registry by replacing its images with their own malicious, backdoored, infected malware ones. Attacker could create a new user, set it to be admin, and they could do whatever they wanted to, even with the Docker command line tool. Their write-up walks through everything that I had just showcased. Now let me actually validate though. I'm going to log out of the hacker account, move back into the admin account. As the admin, I actually want to delete the hacker account so that way we can kind of rerun our script here, because it's worth trying to not even include a cookie for a low privilege session. That write-up, Unit 42's research said, you know what, maybe it's just 0 to admin. You don't even need to have an account. And we didn't see anything in the actual source code that acknowledged one way or another if you were authenticated. So let's just see if we could just spray and pray, not even having any creds to the instance, create a new hacker account. Let's run our exploit script one more time, and we still get a 201 response. So let me get back to the web browser. Here I am at Harbor. I'm gonna hit F5 on my keyboard to refresh the page. You didn't even need credentials. You didn't even need a session. You didn't need a low privilege account. It is truly 0 to admin, point and shoot, compromise that Harbor instance. And all it took was a little JSON blob in our API request with the field and property that really would just decode it, unravel, and unwrap it to populate the user struct and model without any extra validation on extra fields. Anyway, I have been talking, rambling, and yapping for way too long. I hope you thought this was cool. I hope you thought this was a neat showcase, even just a small, tiny, trivial vulnerability, but a little bit of the supply chain aspect in there when you have this container registry that may very well have vulnerabilities in itself that could then compromise, take over any of the other things included in that registry. And this isn't a hard vulnerability, right? This isn't super complex or sophisticated. It's just a matter of someone being able to take a look through it and look for these potential flaws. And that way we can find and fix vulnerabilities. Thank you so much for watching. Hope you enjoyed this video. Please do all those YouTube algorithm things, like, comment, subscribe, and please give some love to our sponsors. ChainGuard is a new partner and I'm super happy to be with them. So please link in the video description, check them out. See you in the next video.